This second comparator circuit differs very slightly from the first one in the fact that I've now changed the input from this first voltage divider is now being fed into the non-inverting input of the three comparators. The three fixed references, the 2.5, the 5 volts and the 7.5 volts, these are now being fed into the inverting inputs. And the function of the comparator has now switched. So this time when it is hot, all of the LEDs are off, and as the temperature falls, in turn, the LEDs will come on. The reason for that is because the inverting and non-inverting inputs have been turned round. So here at the moment, in a hot temperature, I'm getting 2 volts. That 2 volts is less than 2.5, less than 5, and less than 7.5. So the more dominant voltage at the comparators is the 2.5 volts, and therefore it's giving an off signal or a low signal out, so therefore not switching on LED 3. Similarly with comparator 2, I'm feeding in 2.09 volts from the thermistor. It's getting compared to the 5 volts. The more dominant voltage obviously is the 5 volts, so comparator 2 is giving out a low signal, which obviously is switching off LED 2, and so on. As the temperature falls, there for example, we have now got a voltage of 3.77 volts. So comparator 3 is now comparing 3.77 at the inverting input to the 2.5 at the non-inverting input, and therefore the more dominant voltage is the 3.77, and that's why the comparator is now giving a high signal out, which is switching on LED 3. This continues. Here we've now got 5.58 volts is getting compared to the fixed reference of the 5 volts. So the 5.58 volts is the more dominant, giving a high output, LED 2 is on, and so on.